by the manufacturing sector. And the manufacturing sector is also responsible for about 22% of carbon emissions. So energy needs to be used more efficiently with a more resilient energy system, and that requires innovation. So there are a number of market failures that kind of have necessitated the manufacturing institutes, and I'll briefly touch on 3 here. So the first is underinvestment in knowledge and skills. It's not always possible for firms to monopolize the benefits of their research and development, which can lead to underinvestment. And the federal research and development portfolio tends to emphasize basic research with relatively few programs and projects inspired by users of new knowledge in the manufacturing sector. These use-inspired investments, to use Donald Stokes' term, are often the most productive kind of federal R&D spending. Another market failure is weak cooperation across supply chains and within regions. So short-term price considerations and stiff competition can lead to arm's length relationships between suppliers and customers that can impede learning opportunities. So Josh Whitford and his colleagues have shown that more collaborative and network relationships that can accelerate innovation across the supply chain can be blocked by stiff price competition. Similarly, the McKinsey Global Institute has called for deeper industry cooperation and a new level of coordination across supply chains. So this erosion of the supply chain it is damaging to the industrial commons and may necessitate government intervention. The third is unfair international competition, and this is something ITIF has documented extensively, especially around issues of innovation mercantilism. So that enables countries to favor their domestic firms, especially manufacturing firms that are the manufacturing sector that's favored for its developmental and export potential. So the decline in the U.S. manufacturing sector during the 2000s demonstrates the downsides of these policies. So while ideally there would be a level playing field, it's not always the case, and policy needs to address this reality. Now we'll move on to the Manufacturing USA and the institutes sponsored by DOE. So the Manufacturing USA began in 2012 and received congressional authorization with a bipartisan Revitalize American Manufacturing Innovation Act of 2014. So today, the Department of Defense, NIST, and Department of Energy sponsor 14 institutes covering a wide range of issues affecting the manufacturing sector. And as you can see on the slide, most states are involved in some way or another with the network. So the Advanced Manufacturing Office at the Department of Energy oversees the 5 manufacturing institutes. It has 5 kind of broad goals, which include improving productivity and energy efficiency of U.S. manufacturing, reducing the energy and resource impacts of manufactured goods, transitioning DOE-supported innovative technologies into U.S. manufacturing, and strengthening and advancing the U.S. manufacturing workforce. There are 3 sub-programs at the Advanced Manufacturing Office, the largest of which is its Research and Development Consortia, which includes the Critical Materials Hub and Manufacturing Demonstration Facility, in addition to the 5 manufacturing institutes. All right. The technologies the institutes focus on emerged from the Advanced Manufacturing Partnership and the DOE's 2015 Quadrennial Technology Review. The selection process to determine the hosts and scope of the institutions was competitive, involving requests for information, workshops, and competitive proposal selection process. So each institute has its own cooperative agreement with the Department of Energy, so membership structure and intellectual property rules vary by institute, as well as differences due to the different technological challenges each faces. So all agreements are for 5 years, and there's a required minimum 1-to-1 non-federal cost share. Additionally, each institute has an embedded manufacturing extension partnership representative, and all of the institutes have workforce and training programs. So now I'm going to turn to the 5 institutes. The first, Power America, is the oldest, focusing on power electronics and wide bandgap semiconductors more narrowly. So wide bandgap semiconductors can operate at higher temperatures, frequencies, and voltages than silicon semiconductors, which allows devices that use them to operate more efficiently, as well as can reduce the size of the devices. So data centers could potentially save 12% of their primary energy costs by switching to wide bandgap semiconductors. Power America is fully integrated into North Carolina State University and has 50 members. One of their first major projects was working with XFAB, a foundry in Texas, to convert 150 millimeter silicon line to silicon carbide, which is a wide bandgap semiconductor, which they found to be cheaper and faster than constructing a new foundry themselves. And an additional project they worked on was creating an open domain production process for silicon carbide called Precise, which can be licensed by firms to then produce at XFAB. So the Institute for Advanced Composites Manufacturing Innovation, IACME, focuses on composites. Composite materials are made up of fibers embedded in a matrix that can have a variety of properties. Carbon composites are stronger, lighter, and more flexible than standard metal alternatives, and this has led to the widespread adoption of composites in the aerospace sector, but high costs have impeded more widespread adoption. So IACME is focused on developing shared infrastructure and has a distributed model around its technology areas, which include automotive, compressed gas storage, wind, and materials and modeling. So one of their facilities is a COMET facility in Boulder, adjacent to the National Renewable Energy Lab's National Wind Technology Center, and they have the capacity to build prototype blades there. So these blades made from composites are lighter and larger. So a 100-meter wind turbine blade made from carbon fiber instead of glass fiber would weigh about 28% less, and the larger the blade, the more power that can be generated. And additionally, membership for IACME has increased from 55 to about 170 now since its founding. So Power America and IACME are the oldest and most well-established of the institutes. The other 3 are all just a little over a year old. So CESME, the Clean Energy Smart Manufacturing Innovation Institute, located in Los Angeles, focuses on smart manufacturing. So smart manufacturing uses advanced sensors, controls, platforms, and modeling to take advantage of data flows to the potential to reduce U.S. manufacturing energy use by 15 billion annually. Unique among the DOE institutes is CESME's partnership with the City of Los Angeles, where they're co-developing a cyber makerspace for hardware and software. Additionally, the Institute has regional manufacturing centers, which build on the pre-existing capabilities of the host institutions, typically universities, as well as some regional specialization that enables them to better connect with small and medium-sized manufacturers. So Rapid focuses on the chemical industry, which uses more primary energy than any of the other manufacturing industries, and specifically on modular chemical process intensification, which is a set of steps, techniques that streamlines the steps in the chemical manufacturing process, which reduces the capital cost and improves efficiency. Rapid is led by the American Institute of Chemical Engineers, professional association, and is organized around 6 focus areas: chemical and commodity processing, natural gas upgrading, renewable bioproducts, modeling and simulation, intensified process fundamentals, and module manufacturing. Rapid may end up looking towards the American Institute of Chemical Engineers Center for Process Safety as a model for its long-term sustainability. Cool. And the final institute is Remade, which focuses on remanufacturing and recycling. And a large percentage of the products produced by manufacturers and the energy embodied in those products ends up in U.S. landfills every year. So Remade's goal is to reduce the embodied energy, lowering the cost of production and the environmental impact of manufactured goods. Remade is led by the Sustainable Manufacturing Innovation Alliance and headquartered in the Rochester, New York area. Its current membership is 69 organizations, and unique among the institutes is its large proportion of trade associations, which they view as crucial avenues for dissemination of new knowledge and technologies, and includes the American Chemistry Council. Remade has received strong state support from New York as well as a number of other states. And with that, I'll turn it over to David.
Great, thank you, Peter. Let me just say a bit about how we did the study, and that'll provide some context for the findings and recommendations. So Peter has given you an overview of why these institutes are important and the market failures that justify them, as well as sort of sketching what they do. It was our pleasure to be able to go out to a couple of them. We visited IACME in Oak Ridge and Power America down in Raleigh. And we also talked to the directors of all the other institutes just to get a feel for how it's going, the challenges that they face. We also had a chance to visit with some of the member companies, although we're also going to hear today from some of the industry participants, which I think is a very important perspective on this new initiative. So what we found in talking to those folks is that these institutes are ambitious, and they're doing something new. And the main message that we would share with policymakers here is that we need to be patient. They're starting to achieve the goals. As Peter mentioned, a couple of them are 3 years old, so 3 years into the proposed 5-year cycle. But the 3 most recent ones are really 12 months to 18 months old. And it takes a while to build something like this. Many of the partners haven't necessarily worked together before. We're talking about bringing together a large number of collaborators with diverse interests. And that means that there's a negotiation process, and it takes a while to get the things started up. All of them have written roadmaps, so that also is an important step, but it's all in the manner of the startup phase. So I think the youngest ones have now started to issue project calls. So the typical pattern is they'll develop a roadmap, identify gaps or opportunities, and then issue a project call for the members to start doing work to fill those gaps. And in most cases, these projects are either just beginning. In some cases, the older institutes have some results. But our main message here is this is an experiment. It's an important experiment. It's an institutional innovation for the United States in the manufacturing sector, which is an important sector, and we need to give them time to develop. But I think we see enough, especially from the older ones, to feel like there are some successes, and it's pointed in the right direction. Peter mentioned a couple. For instance, XFAB at Power America is really making progress. The John Deere Company, which is one of the members of Power America, said that the relationship had accelerated their power electronics program by 5 years, which is a pretty significant leap forward. There may be a time when we can declare, one of these things a failure. There's no reason to expect every single one of the institutes to work perfectly, but it's too soon to make that kind of judgment. So our recommendations, the first one, to continue to fund the existing institutes. This is much less of a concern than it was a month ago or 2 months ago. So these were proposed to be zeroed out by the administration, but Congress has not taken up that proposal. We didn't really talk about the possibility of growing the program. There is in the current budget the possibility of a new institute, and I think that's a good idea. It's good to expand it, but it's also important to sustain the investment that we've made, and I think that's the highest priority. Second recommendation is to give the institutes more flexibility. One of the things we heard when we talked to people is that there's a little bit of a heavy hand from headquarters that they perceive, especially as they move into a process of becoming more self-sustaining, and they have to raise private funds that they don't necessarily have the autonomy to use the funds that they're raising on their own as they would like. So this is a challenge that really rests with the relationship with DOE that needs to be worked out. The next two, dealing with small and medium manufacturers and with the workforce. These are sort of generic challenges, I think, for all of the institutes. These are critical constituents in the manufacturing sector, right? The bulk of our manufacturing companies are small and medium manufacturers. They're the base of the supply chain, and they have challenges innovating. Similarly with the workforce, the public investment in workforce training has been cut back over the last few decades. Workers have weaker attachments to companies than they used to. So both of these are crucial constituencies to bring along. The institutes are all taking steps to try to address this, but we felt like they can do more. There have been some important developments over the last year. For instance, the NIST's Manufacturing Extension Partnership Program now has embedded personnel. So these are people who are specifically meant to connect the institutes with the small and medium-sized manufacturers. The institute workforce directors have a network now. They meet regularly. A couple of them have really taken leadership roles in reaching out to the sort of mid-skill technician. Now, for some of these institutes, they're developing new technologies. They're not in practice yet, so the training task is more focused on research and engineering. But we would encourage them to try to think about the mid-skill level, which is for DOE especially not kind of worker that they've had to work with before. So it's a science agency. They're very well-established procedures for dealing with postdocs, with PhD students, even with graduate students and undergraduates, but they don't really think that much about high school and community college level. So that's a challenge for the agency and for these institutes in particular. And then the last one is to explain to the public, why is DOE involved in manufacturing? It doesn't really seem like a logical thing to the average person that the Department of Energy should encompass manufacturing in its mission, but it should. Manufacturing is, as Peter mentioned, a major consumer of energy. There are opportunities to improve the way that consumption occurs. And also, energy industry is a huge consumer of manufactured goods. So the shale gas boom was a major driver of the recovery of manufacturing after the recession. And as new energy technologies emerge, there's an opportunity for these new technologies to also pull the sector forward. So we feel like DOE can do a better job, especially at the senior leadership levels, of explaining why the manufacturing program exists. It is nested in the Energy Efficiency and Renewable Energy Office, but it really works across the whole department, and it has relationships with fossil energy, with nuclear energy. So it should be seen, I think, as a program that transcends the EERE office. And then last, I think the most important recommendation that I want to tee up for discussion is the possibility of providing some kind of ongoing support to the institutes. DOE, as Peter mentioned, has a 5-year cooperative agreement with each institute. The plan is that the institutes will transition to fully private support. After that time, there is a covering legislation that deals with the NIST institutes, and that legislation requires that funding end after 7 years. But even after 7 years, there may be some virtues in having some kind of ongoing public support. We suggest something like 20 to 30% of the budget, so the Institute will still have a strong incentive to seek members, and the cost sharing, I think, is a very important signal of whether the Institute is serving the purpose that it's meant to, which is to advance industry objectives. But having some kind of base funding from the federal government would, I think, give confidence to the members that there's a core of funding there. It will give management some flexibility, not have to be necessarily raising money or thinking about where their next paycheck is going to come from all the time. It also potentially gives more voice to the weakest constituents in the centers, which we see as the small and medium-sized manufacturing and workforce. So these are programs that are going to be more at risk if the budgets are constrained or if the budgets are primarily driven by the largest members. And one example to keep in mind here is Semitech. So Semitech was created to address weaknesses in the semiconductor manufacturing industry, which was under threat in the 1980s. It was originally started with public funds from the Department of Defense, and over time it has transitioned to be an entirely private collaborative body, and I think it's still serving a valuable function, but it has been detached somewhat from the national missions that originally motivated it. And so if you have some federal contribution over time, I think it will help keep the institutes more connected to the missions for which they were originally set up. And then the last point, if you look at the counterpart programs in other countries, the best known example is the Fraunhofer Institutes in Germany. Fraunhofer, at least in principle, has a one-third, one-third, one-third model. So a third of their funding comes from the federal government in Germany, a third from the states, and a third from the private sector. Some people that we've talked to said, well, really the federal share is even more than that. But in any case, they have some kind of ongoing support from the public sector. And that's pretty much the pattern across all the programs that are like the manufacturing institutes in other countries. So that's the one we would leave for the folks here in DC to think about, and hopefully we'll have some further discussion of that as we move forward. So that's the presentation of the paper. As I mentioned, it's available on our website, and we certainly welcome your comments and thoughts and reactions to it. And with that, I'm going to ask the panel to come on up, and I will introduce them, and we'll proceed to the next portion of the program. So we're going to take, I think, a pause while we reset the camera, and we'll be back with you. Great. So thanks again to all of you here in the room for joining us, as well as folks online. If you'd like to ask questions from online, please use the hashtag ITIF Energy, and they'll be relayed up to us. So we're first going to begin this part of the program with some brief remarks from the panelists from whom you haven't heard yet. And I'll just introduce them, and then we'll have some discussion amongst the panel, and then we'll open it up to questions. So, so the speakers include Gina Oliver. So Gina is with the American Chemistry Council. She's on the automotive team there and is a senior director for automotive plastics. Has long experience in the industry And in particular, as Peter mentioned, the American Chemistry Council is a member of several of the institutes, and Gina has worked closely with IACME, the Composites Institute in Knoxville, so she will speak to that one in particular, as well as perhaps talk about other issues. Alain Charles with Infineon, he's a semiconductor manager and expert in that field, also with decades of experience. Infineon is a partner or a member of Power America, so the Power Electronics Institute down in Raleigh, and Alain has worked with them, so may speak to that institute in particular. And then finally, joining us from Cleveland is Sue Helper. So Sue, friend and colleague from Case Western University. We worked together in the government when the institutes were being set up. Sue served as the chief economist at the Department of Commerce when she was in the government, and has done extensive academic research on manufacturing and especially on automotive supply chains and globalization. So she is on our high-tech robot, and we'll look forward to hearing her remarks. So we'll start with Gina, and then Alain, and then Sue, and then we'll have some discussion, which I'll moderate, and then we'll look forward to your questions. So thanks. Gina.
Great. Thank you. Thank you, David. Everyone can hear me all right? Okay, perfect. Thank you. A little bit about the American Chemistry Council. We are a trade organization representing the largest U.S. chemical companies. In particular, I sit on over the automotive market team. We're part of our plastics division, 17 member companies strong in the plastics division automotive team. For the automotive plastics market, to give some context, we're representing over 75,000 jobs in 1,700 plants across 45 states across the United States. So significant footprint there for automotive plastics. The team, my team in particular, works together on a pre-competitive basis to provide innovative solutions, working together with the whole automotive value chain to the OEMs. And particularly, we're working to provide lightweight materials. These are innovations that are sorely needed, especially as we're transitioning more and more into things like autonomous vehicles, electrification, ride-sharing platforms. All of these things will need to maintain vehicle performance, but because they all add significant weight to vehicles, lightweighting is going to be more and more important, and plastic and composites in particular are going to be integral in that solution. So as an organization, in particular the auto team, we do advocate for obviously the increased use of plastic and composites, and we do that on a pre-competitive basis with the automotive industry. The challenge for us significantly has been the fact that the automotive industry is very much a metals-based, historically metals-based organization. And because of that, they tend to lack confidence in composite solutions, and they tend to not want to embrace composite solutions as much because they just have not as much familiarity and certainly not the workforce training needed in order to do that. So recognizing that for several years now, ACC has been advocating pretty heavily for the creation of a development facility in the U.S. You mentioned Fraunhofer. That's something that our members and the industry has used quite a bit, but we wanted to make sure that we had that type of a development and demonstration facility here in the United States. So we worked beginning several years ago now for the establishment of that, and luckily enough, we've got now the institute, IACME. We've been very proud to be a strong catalyst in the creation of IACME. And I think, as Peter mentioned, this IACME in particular does foster large-scale deployment for advanced composites for automotive, wind, and compressed natural gas. As part of that, recognizing that we also needed to establish the supply chain. So as we're deploying these innovations, we also need to have the supply chain to make sure that we are able to serve the needs. And perhaps more importantly, in our minds, is to help secure the U.S. as a global leader for advanced manufacturing. So ACC and its members have been part of IACME from preconception, as I described, through formation. I think also was mentioned that the industry focus really needs to consider longevity past the 5-year term, which I'm going to talk about a little bit more in a moment. We do have 170 members right now and growing, and thinking about all of the investments that those members have made to date. It's integral that these, not just IACME, but the rest of the institutes are able to continue and grow and maintain our security in terms of energy and economic and jobs for the U.S. So obviously, as I mentioned, critical to the success is going to be protecting those membership investments, not just ACC members, but all of the IACME member investments. Sustainability, as David mentioned in his recommendations, is something we definitely agree is an important component, not just for DOE's investment, but also for member investments as well. We agree flexibility is needed in terms of private sector and how those funds can be used going forward. And we think opportunities that DOE could explore that would help provide sustainability options past year 5 and potentially even indefinitely would be an excellent way to make sure that those investments are sustained and that we can gain new members, because new members don't want to come on board unless they feel secure in their investments. So that's it for me for now.
Thanks, Gina. Ilan?
All right, so with Infineon, as you know, is a German company, and we have a subsidiary in the US, which in fact has a big, relatively large footprint in R&D. I'm personally in charge of the research for the wide bandgap gallium nitride semiconductor, so all the power aspect of it. And I joined Infineon when Infineon did acquire International Rectifier. As you know, International Rectifier was one of the leaders in the gallium nitride. So we decided to join Power America for several reasons. We believe it's very important to network, even with people that can be sometimes our competitor. So it's a good way of meeting. One thing that did interest us in Power America is there was a diversity of members, which I think was good. We did join in 2016, so we were not there in 2015 too busy with the merger of both companies. And since then, we've done quite a few proposals and we've got a few projects ongoing. So I would say the first thing that is of value is that they have some cycle where, like once a year, we go through a road mapping process where every participant somewhat share what they think is important or not, and it's a good way for us to also confront our thinking with some of our competitors' thinking or some of our customers' thinking. So it's a good way of having a good view on some of the academic thinking. So that's the first thing we look at, and through these roadmap, they define basically the main direction or the main focus point that the institute will support, and that is helping us to, let's say, decide also with whom we should be partnering. So, for example, IR and Infineon was pretty strong in doing all the power flow chain that goes from like the mid voltage to the microprocessor in a server farm, right? So we have done a project, we have submitted a project with Virginia Tech on how to improve that flow so that we improve efficiency from like 70% today to about more than 90% efficiency overall. And that's probably for the next generation of server farm. That's something that is long-term enough where there is a lot of knowledge in the academics that we can go and learn from and work with. We can provide them a lot of infrastructure. We have silicon carbide, we have gallium nitride, so we can help speed up this project. And in exchange, what we get is some of the know-how from university. We hope that some of the students that we will be working with might join us. So overall, it's not so much for the funding of the money that we are interested. It's more for all the side things we get, the roadmap aspect, the academic access, and the workforce. Now, looking for the future, I think there are a few things that will need to be changed in the way the institute is working. I think Power America is funded until January 2020, if I got that right. And I think the way the IP, intellectual property, is managed today within the institute is maybe okay while there is funding from the government, but when it will go as its own self-funded organization with money coming only from members, I think the IP setup today is not appropriate. It will give problem because today the way it works is depending on the membership type that you're taking, your right to the IP are different. So basically, who pay the most as the first access. Simplified view, but roughly the way it is. And I think in the future, because there are many small and medium companies also in the institute, they cannot afford to pay the higher fee that maybe bigger company can pay. And I think it's very important that they reconsider the way the IP is set up if they want to go with a member-funded type approach. The main challenge I see for the future. We've been trying to discuss that point with the management team of Power America, and I think they do realize this. It's going to take some effort and some, I guess, negotiation, but I'm positive. Thank you.
Thanks very much. Sue, unmute. Still need to unmute. What? Can we call her? Yep, we're still not hearing you.
Apologies, I was on mute. Can you hear me now?
Now we got you. Welcome.
Okay, I wanted to say one thing about supply chains and then a little bit more about workforce. So I think on supply chains, this is one of the issues is helping small manufacturers actually get the chance to implement some of these technologies. And there's a lot of purchasing policies at these big companies that are really focused on piece price. And new technology may often cost more in terms of the product, but the performance benefits and the life cycle benefits are greater. So I guess one thought is just, can these institutes have projects where they have some demonstration projects on how you would do life cycle analysis for their particular technology? And I think that's actually key not only for the small companies, but also for the workforce side, to give these companies some profits that they can use for training, among other things. So to turn to the training issues, typically we think about labor force and workforce policies after the technology has largely been developed. And I think that's a mistake for a couple reasons. One is that it means the technology itself is not implemented as effectively, and second, it doesn't lead to the creation of particularly good jobs. So often what underlies, I think implicitly, the engineers that are developing the technology is a kind of Taylorist view that's efficient to separate the brain work and the hand work. And instead, I think what we've seen from Toyota and others is that these frontline workers have access to knowledge that no one else has. So they're constantly with the machines. They can constantly see if it's working right or not. And if you give those workers skills and a communication channel to report what they're seeing, report the problems that they might see, things can work better. An example, I guess, just a quick example of how this can work. I actually spent an afternoon at the manufacturing demonstration facility at Oak Ridge, and they're doing some really cool stuff where they're trying to do additive manufacturing for tooling, which actually makes the forms that actually make products anyway. So you can imagine, I mean, I think people tend to think of additive manufacturing as giving the designer sort of molecule by molecule control over how stuff is deposited, and that's actually not true. That how the mechanism by which you use to lay down a layer by layer and build up this product has a big implications for its strength, big implications for the dimensions. And so having a worker, a knowledgeable worker, watching this and having the ability to contribute to the design is really important. So I guess the conclusion is we need to really, I think, integrate technology design, workforce training, and work organization. I have a couple of ideas about how to do this. First is just to make sure that we design jobs so that workers have the opportunity to give wisdom to the machines. So that instead of having the frontline worker be somebody who stands there and calls when there's a problem, have them actually implement some of the early stages of problem solving, etc. There definitely, I think, need to be forums where there's companies, unions, training providers getting together early in the stages of the technology development so you actually have within the companies, it's not just the workforce people separately from the technology designers, but together. That'd be a first recommendation. A second recommendation would be problem-solving training for all workers. A third would be some kind of apprenticeship in debugging that particular technology and ongoing training for those in those skills. So those are, I guess, some thoughts on workforce training. I think the institutes are well aware of these issues and are doing really exciting work and can just be doing a little bit more, I think, on the workforce and the supply chain side.
Great, thanks very much, Sue. Gina, maybe we circle back to you. Sue, we need you to mute just till we call you again. If you want to say something, just wave your hand. So you had mentioned that the workers are unfamiliar with at least with the materials in integrating composites into the automotive supply chain. So how do you see that being addressed? And are there examples where you're making progress on that front?
Yeah, and actually, Sue's comment made me recognize and that I should have mentioned, or I should mention, that one of the ways IACME is really helping with that, they have a variety of workforce initiatives going on, but one of the ones I hear about the most from members that they really find beneficial is an internship program. So they're getting either recent graduates or nearly graduated folks out of school. They put them on a project, to Sue's point, so that they're working with the designers the whole project through. And then what's happening is we're getting those folks hired right away into the automotive value chain because now they've got experience, direct experience that everybody's seeking to the point that I mentioned is a hindrance. So it's been particularly one of our member companies, DuPont, recently mentioned to me that they're filling jobs that they weren't able to fill before because there simply wasn't the pipeline of talent. And because of IACME, they've now got a direct pipeline and experienced workers that they can tap into. So that is a big success for IACME, and I think something that, to Sue's point, all of the institutes could be doing. It works really well for IACME.
We heard a little bit as well when we were there about IACME and Lyft collaborating, and they have a new facility in Detroit that is specifically targeting at the auto supply at the automotive industry.
Correct.
Yeah.
Yep, scale-up facility there, so that was a pretty big achievement. And sharing the space with the aluminum folks. We both have a lot of the same challenges, and we collaborate already on lightweighting solutions. Future vehicles are going to be multi-material. We all know that, but it's the right material in the right place. So everyone in the value chain needs to understand what the advanced materials are so that they can create those solutions.
Thanks. Alana, I was very interested in your comments about the road mapping process. That's a fascinating exercise, and I think it is one of the real virtues of the institutes that they bring the different kinds of parties together to, would you say that this process kind of sets expectations about the future, or, I mean, how do you see the output of that process?
Well, it helps define the direction in which the institute will help and finance to attack, let's say, the main top item shown on the roadmap. So, I mean, it is important as a member to participate into it, because if you don't, then the focus might not be on what you want. But I think on the other hand, it brings people from another horizon than the one we have. So, yes, I think it's very key to the process of organization.
And what do you see as some of the main, the biggest objectives for Power America? I know they've stated some goals, and what is the industry kind of expecting as the next stage in the development of these wide bandgap electronics?
I mean, wide bandgap semiconductor are still, I think that we have passed the stage where the question was, will they happen, not happen, will it come? I think now it's not so much the if, it's more the when. But there are still quite a few hurdles to move or to fix. And I think Power America should evolve into something where they are basically helping taking out these roadblocks for the industry. The focus they've been putting, I mean, there are some contradiction also in what they do. The focus they've done with this silicon carbide foundry using XFAB is good in what it has generated. It did allow a small company to have access to that type of technology. On the other hand, on gallium nitride, they totally refuse to consider working on the zero epitaxy of gallium on silicon, gallium nitride on silicon, which is absolutely key for that technology. So a bit of contradiction there sometimes. But so I think they should evolve more into trying to help taking out the roadblock for the adoption of the technology. So accelerating the adoption of this technology.
Sue, I wanted to circle back to you on the question of international competition, and I know this is a subject you've thought a lot about, international competition, particularly as it relates to the U.S.'s position with the supply chain and with workforce. And, how do you see, I realize this is a very general question, so maybe you want to take it to a specific industry, but do you see the U.S. moving in a more competitive direction, kind of on the high road that you've written about?
Yeah, I think these institutes are really key to moving toward a high road. That part of what's happened is that because the U.S. has been sort of fragmented in terms of its supply chain and its workforce policies, we haven't been able to compete with the Germanys and the Japans and the Koreas of the world. And so I think, so one example, I guess maybe I'll return to this tooling thing in additive manufacturing. One of the reasons that companies aren't doing their tooling here is it requires big blocks of metal to start in the traditional way, and then you shave it down. We don't cast big blocks of metal in the U.S. anymore. It's an industry that's moved to Brazil or China. And so then the tendency is to have the whole tool made there rather than flying or shipping a huge block of metal. So additive manufacturing is a way of compensating for a loss of a particular industry. So I think that would be one example. Another example, I think, is building clusters of practice. You're starting to see, in some of the cases, firms that talk to each other. And the examples that we've heard from American Chemistry Council, from Infineon, and to be part of that conversation, you have to be in the U.S. And so that's another thing. Promotes the development of industry and technology in the U.S.
Thanks. And one more topic I want to open up before we go to Q&A, and that's the role of the states, which we didn't emphasize, I think, in our presentation, but I want to make sure people are aware that they do play a role, that they're partners in the institutes in different ways. Each institute is a little bit different in how it relates to the states. There are a number of them that have gotten pretty big investments of state funds. Others where the states primarily play through working with their state universities, helping state universities participate in projects by providing cost share and so on. But the states are really the primary locus, I think, of manufacturing strategy in the country. And the U.S., the federal government's role is often, sort of coordinating and providing resources to that strategy. And I think the institutes fit with that. But the states haven't been as integrally involved, I think, as they might be. And that's another area where the institutes can continue to develop. And we heard somewhat different stories from the five that we talked to about that. And I don't know whether anybody on the panel wants to speak to the state role here, but it was my impression, looking back at my experience in helping set up the program, that we underemphasized it somewhat. I mentioned the MEP embedded embed program. So each of the institutes has an MEP person embedded now, and those MEP programs are state partnership programs, so there's kind of a crosswalk to the state as well there. But I do think that's something that can continue to be developed.
So for IACME, we have very strong state support, in addition, of course, to the national labs and the research universities. We get state funding and state funding match for projects that are conducted in a particular state. The states that we have a focus on are Tennessee, Indiana, Ohio, Colorado, and of course Michigan. You mentioned the IACME Lift Shared Facility. And in particular, it's on a state-by-state basis how strong of a match they provide. Indiana's doing really well. They're doing a 3-to-1 match for projects that will be located in their state. And, we work very closely, the board of directors works very closely with each of the state economic development corporations. So they're very heavily invested and involved in creating jobs in their states, but also working in a partnership with other states and nationally, recognizing the need to grow and create that workforce development.
Great, thanks. Any other comments?
Well, through Power America, I don't think I don't really have any comment on this, but regarding state influence, for example, we have our site for gallium nitride growth on silicon based in Mesa, in Arizona. And I have to say that the state has been very helpful, helping us with training with people, and it's been very important.
Great, thanks. Okay, so let me open it up for questions. If you are called upon, please identify yourself and wait for the mic, and then identify yourself. And if you'd like to ask a question from online, please use the hashtag ITIF Energy, and those will be shared with the room here. So let me see who's first, please.
I'm Bob Hershey. I'm a consultant. Could you talk about some of the successful projects within your various areas?
I can start with the first one that we are doing with Virginia Tech. I think we're just in the beginning, so it's not concluded yet. But I think if it's successful, and we have all reason to believe it will be, I think it will provide big advantage to many of U.S. corporations that are potential customer of us, like Google, Amazon, several suppliers. And it's definitely an advantage for the U.S. Yeah. There are other projects that we do, like for example, we work on some, let's say, more innovative device type things that maybe the company would not invest itself in because it's too innovative for now. By having this support from Power America, we can start to look at it and start to do a prospective work that might at the end show that there is a way of, let's say, creating a new potential market there. So there are, I think in that regard, there are some good success that we have experienced. They are not yet finished because we only joined in 2016.
I'll just mention one company that we had a chance to visit when we were down in Oak Ridge. Now, the company is, I don't know exactly which project out of their development cycle they work with the Institute on, but they're very closely aligned with the Institute. And the company is called Local Motors, and it's developing a composite, basically a small shuttle vehicle. So it's going to be autonomous, electric, and composite built. And they showed us some prototypes, and I was kind of inspired. So I kind of envision part of the autonomous revolution occurring in cities. And one could imagine a kind of district set aside where traditional cars aren't allowed in, and these shuttle vehicles kind of run people around. And I think that's sort of the vision that they're working towards. And as a relatively small startup company, they spoke very highly of their interactions with the Institute. They've gotten a couple of projects, but I think also, and this is something Alain mentioned, is the kind of collaboration, the ability to develop relationships with other companies, either companies working on something similar or companies that might be in their supply chain or companies that they might sell to. I think they saw all of those things evolving from the Institute. So that was, to me, kind of, if I look back on our research, that was kind of the most fun thing that we saw.
Yeah, it's an exciting development, an exciting project. It's also heavily relies on 3D printing.
Yeah, I mean, they're doing everything, right? It's like, wasn't enough
exactly.
to be, to just have an autonomous
Yes.
vehicle. It has to be 3D
Yes.
printed. I mean, that's
They're
really
throwing it
quite,
all on the
they're very
pile.
visionary, yeah.
It's a great example.
Yep, here.
Hi,
John.
Samantha Pajaco at ASME. Can you speak a little bit more to how you think it would play out in terms of IP if the institutes don't receive federal funding, especially the difference in the effect on the small and mediums and then the large businesses that are at the institutes?
Well, I mean, we have experience also. We are part of CPES also. So I would say they should use similar model. At the moment, the fact that let's say the biggest or the richest member tend to get more than the smaller one, I think is not sustainable. If you want to be able to survive without, let's say, some government funding, you need to get more members. To get more members, I think you have to make sure that you put them on a equal foot, whether they're small or they're big. And as I say, you have to shift also the objective to maybe taking out a roadblock that we see for the adoption of wideband gap instead of maybe doing things that are a bit more, or let's say less of general interest. Okay, because as it is today, I think the bigger member have a bit too much of influence into some of the direction and some of the things that are done. Like, for example, there is a start of doing this member-funded project type. So basically, these projects are decided by the members, but are not receiving funds from the government. And the problem with the IP rule, it makes that we can only allow to participate into these as long as the project doesn't bring any IP. Because if it brings IP, because we're only affiliate and we are not like the prime members, we know that we might just pay something to develop an IP that we won't even be able to use. So that is a problem.
I have the impression that many institutions, and this is not confined to these institutes at all, but as at universities you see this as well, the illusion that IP is going to pay, for a lot. I mean, that the institution is going to be able to sustain itself on that. Whereas it often, in my impression, and we heard some discussion of this as well in our interviews, that it can become as much a barrier as an asset, and that the focus of the discussion becomes around, splitting up a relatively small pie rather than growing the pie. So it would be a shame if that becomes a barrier to the further development of the institutes. Now, each industry is a little different, right? The role of IP in innovation varies across sectors, so we would expect these models to be somewhat different. But I do think that's an indicator to keep an eye on, to the extent that there are IP disputes arising out of the institutes. That would be a bad sign. And we didn't hear that going on, but I don't think we should expect them to be able to become sustainable on the basis of IP development. That's probably not realistic. Yeah.
Hi, I'm Mike Ducker from JE Austin. I do international development and economic growth. I was just wondering how you I've heard like some startup names and some old industry names, and older industries have tended not to be so open and sharing sort of their future outlook of their industry, of their technologies and other things. And how does the Institute kind of break down those barriers so there is a lot more of an open conversation than maybe traditionally 6 or 7 years ago in the auto industry, that they're actually sharing some of these things than previously?
Gina or Sue?
Well,
You know, why don't you go ahead?
I think what's unique in particular for composites in the automotive industry is that we all need to work together, and we recognize that if we're going to make headway. Certainly, metals have been doing that for a long time, and we know that there's a need there for us to combine forces and work together. And in that spirit, and in the spirit of the creation of IACME, it is certainly thought of as pre-competitive at the most, so that we can get that technology out to the OEMs and create that confidence in using our materials, because it benefits all of us. And it benefits the automotive industry. They're not going to be able to implement these future technologies unless we can deploy it faster. And that's the whole point of IACME's original creation. That was the spirit. And I think the members really embrace that.
We haven't spoken much of the more recent ones like Rapid, but I think the same applies, that this chemical process intensification is meant to be a paradigm change, and requires all of the industry to work together to pull that out.
Yeah, I would just jump in and say that I think the auto companies, really do recognize, as Gina said, that they don't, that they need suppliers to actually make this stuff, and so they've been open about their needs. I think one gap that remains is actually helping suppliers, particularly small suppliers, with investments and making it possible for those investments to pay off. So suppliers kind of get one bet, if you've been maybe a traditional metal stamper, are you going to move into aluminum? Are you going to try magnesium? Are you going to try composite? You can't do all those things. And giving a little bit of guidance, and then also financial help in various forms, whether that takes the form of a long-term contract or something. I think that's a next step that OEMs in a variety of industries, but particularly autos, needs to take.
If I can just mention one more thing to build on that, especially with your comment about the small and medium businesses. In IACME, I can't speak for the other institutes. If you are a small or medium business, you can qualify for a match based on in-kind contributions only. So that's some help that we have set up.
Great, thanks.
Yeah, and I just to add
Go ahead,
one thing.
please.
The reason for us and why it's working is because most of the projects are based on an application for our product. So we do not disclose how we do things. We disclose or how it could be used. So it's more creating a market and proving that it could work in that market more than anything else. And it doesn't matter to us if some competitor can see that, because nobody will only rely on one supplier. So we do need competition.
Anthony Cordetti, I'm with the APLU, and I guess I'm wondering if maybe universities could play like a larger, more integral role in this, because almost each of you mentioned it seems something to do with the university. Mr. Hart, you said states partnering with state universities, or the internship program, or even specifically the Virginia Tech project you guys talked about. So I guess if you guys could elaborate on that, that'd be great.
Yeah, all the institutes have academic partners, and I do think one of the virtues of the arrangement, at least as we conceived it, was for the industry to be able to put a little bit more of a pull on the academic research than if the academics are kind of developing their own ideas for peer review. So maybe these kinds of projects. I mean, it's particularly relevant for engineering schools, which are naturally applied, but nonetheless, it gives them more of a sense of what are the industry problems that need to be fixed, and focus their attention on those. And then, as Alain mentioned, I think also, or maybe even more important, is to get students interested in some of these issues, and give them connections. And obviously for the companies, it's a benefit because they get the potential of hiring them. So I think both of those, both in terms of setting the research agenda and in terms of developing talent that's kind of ready to move into these manufacturing roles, the institutes are playing a useful role. And actually, I don't think I realized until we visited them how integral they are. And also the national labs. I mean, some more than others. At Oak Ridge, obviously, the national lab is a really big player. And so both for the universities and for the labs, there is this sort of pull dimension, I think, that's important.
Hi, Joel Yudkin, High Road Strategies. Back to the workforce question, I get the sense that a lot of the centers, the various centers, are in different places in terms of what they're doing with the on workforce. And are they putting, for two quick questions. One, do they each put together a plan or particular workforce strategy? And and how do we find out more about what they are? And the second, what's the budget? I mean, is there any money allocated in the program, or is that something that's being raised? I'm just not clear about who's funding it and how.
So let me give you my understanding of the overview, and then others can jump in on a particular. So each institute does develop its own plan. Most of them have a committee specifically of members that's focused on workforce. And I believe all the institutes have a workforce director, and those directors get together on a regular basis, which is relatively new. They didn't really start out doing that. But I do think they vary in terms of the emphasis that they put on this. And it depends in part, again, at the extent to which the technology is already out in practice, where there's going to be frontline workers who are dealing with it, whereas in other areas, the technologies are being developed, so they're not in the plant, and so it's the workforce tends to be focused more on the research and engineering side. So I think they vary both in the focus of the workforce effort, but also the emphasis. The one that we heard a lot about, it's not in the DOE group, but in talking to people more generally about the institutes, the LIFT Institute in Detroit is, I think, seen as kind of the leader in workforce development, and as Gina mentioned, they're partnering with IACME in both in their kind of demo facility, but also in the workforce programs. But they vary. I think it's something that that the program leadership is aware of, that they put some emphasis on. And the GAO did a review of the program last year, and this was something that they pointed out. And the folks that we talked to said that Department of Labor is getting more involved with it, which I think would be helpful, connected up with the apprenticeship push. So there's some opportunities for greater cross-agency interaction. And then, of course, the states are a big player in workforce as well. So to some extent, it depends on their interaction with the state programs.
I mean, there are things the Institute do. They organize training for our current workforce. So that is the first thing that Power America did this year, and I think it was extremely successful. And then they have, when they do this annual meeting that we have a review of all the undergraduate and graduate people that are coming and are working on the discipline we're interested in. So I think they do a very good job at promoting what is.
I mean, it's a membership model, so I think each institute develops its own budget. So, I mean, typically there's kind of a tiered membership, so the bigger companies pay more. But I don't think within that pool there's a specific workforce program. Sue?
Yeah, if I can jump in, I would say that it's definitely a mandate in the RAMI Act, but the workforce people, my understanding is, tend to be a little bit siloed, and so there isn't really an opportunity for the workforce considerations to influence the technology development. That the people in control, say, of the project calls tend to be the technology directors. So it seems like one possibility, in terms of if there was going to be an additional round of federal government funding, would be some kind of, competitive grant program to link a technology effort and a workforce effort together to explicitly fund the workforce piece of this. So I think there's some stuff going on, but it definitely could be done with more emphasis and with more integration with the technology development.
Thanks. That's helpful. Other questions? Bill?
A question really to
You should just
Gina.
introduce yourself, because I know you.
I'm Bill Bonvillian with MIT. A question to Gina and Elaine and on the institutes they've been involved in, and then maybe Peter to the other three you mentioned at the outset. What would you say are the most important accomplishments of the two institutes, IACME and Power America, that you've been involved in to date? I mean, what really stands out for you as significant that they've been able to get done? And then maybe, Peter, even though the three institutes that you mentioned are newer, maybe you might want to highlight, something from one or two of those.
I can start. I think the thing I like is the diversity of the membership they bring together and the forum that they bring on the discussion that we can have. I mean, I can talk with company that I would have never met, never think of. We can start off thinking of, maybe we could do this for you, you could do this for us. I mean, it's really a good mix. You got from the academic to the very small startup to maybe the big gorilla as we are, to people that are more on the application side, the user side, people that are more on the supply side, people that are more on the, I would say, scientific side, right? So it's a very good mix, and it does force us to go rethink sometime what we thought as being established. Because my view is, as a big company, that's the biggest danger we got. We're so big that we tend to think everybody should think like us. And going to this meeting tend to put us back onto maybe not. Right? So that to me is good. I like it.
So for us, I think some of our highlights are certainly our membership recruitment. Even though we are one of the first institutes, our membership is very strong, 170 and growing. And so I think that speaks a lot to the commitment of our members and the networking, because we're always getting new companies and we're talking at events. People want to hear what we're doing, and then that's leading them to join IACME in turn. From an administrative perspective, I think one of the great things that we've done is create a sustainability board. So they've been working for a long time now on saying, okay, you know, this is great. We got funding. We're getting the ball rolling. But at the same time, let's start thinking about what we're going to do in the next 5 years. What does that look like? How can we work together? What's a plan? Let's do it. Almost like a road mapping exercise, again, specifically for sustainability. And then in terms of project success, I actually brought a sheet with me, and I wanted to kind of highlight some of the things that the Institute calls successes in terms of projects. They've initiated 10 technology projects. This is probably a couple of years old, so it's more than that right now. In particular, a $3 million Volkswagen project projected to garner a 25% reduction in cost and weight on a production model. And that's expected to be greater than 100,000 units annually for that vehicle. So in the auto world, that's high volume, which is exactly what we were after and one of our major goals. Also, a $1.5 million composite recycling technology center. I didn't bring that up earlier. Why is it important? Because one of the things that we often hear is metals are recyclable and composites aren't. It's actually not true, but there are still some challenges to make it easier that we recognize needed to happen. So that project is expected to initiate the capability to have 100% recyclability within automotive production when it's finished. So, I mean, these are major barriers that have sort of existed, as I mentioned, to create that confidence for OEMs to use our materials, and the same for wind and compressed gas storage.
So I guess I would say for the other three, they're really still new and kind of setting up the preliminary road mapping and really moving on to first project calls. So I don't think technologically there's the success stories there yet. But I think what's interesting is at least in the three new institutes, there's still a willingness to try and experiment a little bit with how they're structured to try and find the best way forward. And I think that kind of gives a nice mix of, you know, there's not a cookie cutter for each institute. And for example, Remade is looking to come up with a master agreement for all companies in members to use their test beds they're developing and to streamline the process there and things of that nature.
Thanks. We have time for one more, if there is one out there. Colin?
Hi, Colin Cunliffe with ITIF. Congress has provided funding for a 6th Clean Energy Manufacturing Institute, and I think DOE is still thinking about what that topic is. For Peter, since you said the genesis came from the 2015 Quadrennial Technology Review for each of these 5 institutes, can you remind us what some of those options for a new institute might be? And then for the other panelists, what would you recommend to the Department of Energy, or would you recommend that a better use of that would be, like David suggested, maybe maintaining the existing institutes past their 5-year mark, but at a reduced level, like 20 to 30%?
Well, looking here, some of the kind of potential options, a lot of them have been kind of covered, and the critical materials hub, so there's other kind of hubs within AMO, have covered some of the issues on the quadrennial report, but I guess there's direct thermal energy conversion, materials, devices, and systems, process heating, waste heat recovery systems, combined heat and power systems. So I don't know what a new institute, what the form would take, but I think there are some interesting potentials, and to see what kind of the stakeholders came up with.
Yeah, I would emphasize the importance of the industry-led nature of these institutes. Now, NIST has a structured program to try to elicit industry proposals, and so that would be, I think, a critical determining factor for new institutes is where, what's industry willing to put money into, where there are big opportunities that wouldn't otherwise be realized.
So for me, if that money were to be allocated across the current institutes instead of creating a sixth institute, I think they would all benefit from adding a life cycle analysis component, per Sue's comment. I think that would bring a very robust ability for these institutes to be successful and really capture the best of investments that have been made so far. Life cycle analysis is expensive, and we need help doing it. And also, it would be very beneficial because then those life cycle analysis assessments would have a streamlined effect, and I think that the institutes could benefit from each other on that. And then also I agree to bolster the workforce component for those institutes that maybe don't have as strong of a workforce component included would be very beneficial.
Sue, do you have any closing thoughts or reactions?
No, I would agree with both of the points that Gina, or all of the points particularly that Gina made, and I think just to, a lot of these new technologies require investments by suppliers, and current purchasing methods are not often set up to help either the buyers or the suppliers manage those well. So I think Gina's point about the life cycle analysis is really good, and of course I agree on the workforce side.
Great. So I think we're going to wrap it up there, and I want to thank Gina, Alain, and Sue for joining us, and thank all of you for coming over this morning. And we look forward to your comments on the reports and continuing this discussion in the future. So thank you very much. We won't see you in Seattle, but we'll see you.
Down the road.
Yeah. Hope to see you. Yeah.
I'm going over, so I'm a professor at our school at but we have some money, so as soon as I get ready, once I get it out of the way, I'm not sure how it will. It's called Picture but I'm more or less here like half my day. I'm just going here calling. So
Ken Jarbo's going to be helping us part of it. I'm going to focus on revising and bringing up to date.